All right. Well, happy Wednesday. We made it. Hopefully you had a good Labor Day. You guys do anything fun? Okay, that's fine. That's a day of rest, I suppose. It's good too. We were out, not Labor Day itself, but the weekend out in Grand Rapids. There's a gaming convention for board games and tabletop games all weekend, Friday, Saturday, Sunday. It was so much fun. We got a new pile of games for the kids to play, for me to play, and it's pretty cool. It's always a good time. All right, so we're going to get into the rest of chapter 2. We got through a lot of it here, maybe half of it or so. And then we'll talk about the very first project. And then next week, we'll start on chapter 3. We'll do our lab for chapter 2. We might, I don't know if we're going to do any of chapter 3. We'll see how far we get with the lab. And then we'll just kind of go from there. So hopefully we'll be back on a regular schedule after that. It can go pretty well. Okay. All right, so let me fire up PyCharm here. And get the right Zybooks here. Get the good one here. So again, I'm going to try and use this to make sure I'm not missing anything, but to give you different examples if I can help it here. Yeah, I think we got through division and modulus, right? Modulo, about as far as we got. So we got a couple more pieces here, and then we should be in pretty good shape for chapter 2. We talk about the project. All right. Cool. Yeah, okay. And there we go. So I don't know if you can see, there's like a real thin white line here. This is about as far as they recommend your text go on a regular screen when you're not zoomed in. Again, I set mine so I can zoom in more. So it's a little easier for you to see on the screen, but generally you don't want the code to go too far on the screen. You have to scroll left and right because that upsets people when they're looking at your code. They don't want to have to scroll left and right. All right, so some basic arithmetic. Right? We did all that. We're talking a little bit about modules here real quick. So the idea with modules is Python will run that script behind the scenes. So remember, when Python runs, you actually tell the Python executable to read the Python file that we wrote. Most people would generally consider Python an interpreted language. It's reading the file and interpreting it and running it as you go. There are some things behind the scenes that are compiled. So it's technically like a hybrid language if you want to be really pedantic about it and get into arguments with people online, because everyone online loves to argue. I'm thoroughly convinced there are no winners in online arguments, though, because no one actually argues to listen. They only want to argue to say what their point is over and over and over again, and they're not willing to change their mind. Right? It's not even like a debate. It's just two people yelling at each other. So whatever. So this is our Python script. So Python will run this one here. What you can do is, instead of making a script that you run and execute right away, you can make a module that can be used in other files. So I can make a module like names.py that just has some information here, and then I can import that module in another Python file. It might seem a little weird, and this is kind of a terrible example of it here, but the idea is there are going to be libraries of code out there that people have written and said, hey, you can use this. All we need to do to use it is import it here, and then we can go and use their code. Yeah. Essentially, yeah. Most of the times we call them libraries. In Python, they're known as modules. I will probably just say library because that's what I'm used to for other languages. Yeah.
It's an introduction to C++. Are we doing C++ or are we doing Python?
Did you get C++? It shouldn't have gotten the C++ book. Hang on. Did I give you the wrong link?
Yeah, the link that I clicked on.
So the code is ever so slightly different. There's 1501 and there's 150. So I've got two different book codes. Did anyone else get the book? Yeah. Do you have the Python version? Okay. Huh. So we should email the Zybook support people and get you the right book, because that's no good. Yeah, we can chat after and see. Make sure you get the right book here. But yeah, the codes are like nearly identical, which is a little weird. Yeah, we'll get you straightened out after. All right, so with that module, then you can use anything in that module, in that library, by the name of the module, which is the name of the file, then dot the variable or something else. So it's names.first, names.last is first and last name. Again, that's not very interesting, but if you want to use like the math library, we can import the math library and not have to reinvent the wheel with all sorts of math stuff. Yeah.
It's the same code that's on the doc.
All right, we'll email those support people and figure it out. Yep. So it's really nice to not have to reinvent the wheel with all the math stuff. And generally, you want your imports at the top. They don't technically have to go at the top, but almost everyone does them at the top. So I'll say, hey, I want to import math. Now, if I want to do something out of the math library, I just say math dot. So math is the library, the module name. And now I can do, hey, what is tau of something? What is pi? What is the arc sign? What is the cosine of something? What's an exponent? What's the fabs is something absolute value. Again, I don't remember why there's an F here, but that's okay. You get all sorts of cool things. You can take the log of something. You can take the sine of something. So all sorts of cool math things that we can do. So I think there's a square root in here, right? Where's the square root? Probably with S, right? Yeah, square root. So you can take the square root of a number, right? Which is fun. Exponent, right? You can do it to the power of, right, with our notation. But sometimes you want to use the exponent function. So we can say, hey, let's get a number here. So this is a number to square root. Is an int of an input, right? We're going to say, hey, give me an input, turn it into an integer. A number, find the square root of, and then we can print the square root of, and then we can just comma separate right in here. So my number to square root. Did I spell it wrong? I did. It's QUA. It's nice of it to tell me I spelled wrong. Square root is, and then in here we're just going to say math.square root, and we get this set of parentheses, right? Just like input uses parentheses. We'll say here's the number to square root. We give it a value. Again, we could just give it like 10. It doesn't have to be a variable, but we like using variables because it makes our program more interesting when we run it here. So we'll use the number to square root. And I'll right click and run, or go hit the run button here. We have 10 and 10 and 10, sure, 10. So square root of 10 is 3.16 something, right? Sounds about right. That's pretty reasonable. I know you're amazed Python can do math, right? Sure. So we can use that math library. Now, if you want, and this is real bad usually here, you can write a module or a library that also has code that will run when you run it itself. It's real awkward here. So you might see this thing, if name equals main, which doesn't make any sense till we get to the next chapter anyway. But if you see this here, that means if you run the pet names py module, then this will run. If you import pet names in a different Python file, it will not run because it was not the main file being run. That's all. So it's a way to have code there, but not actually run it unless you really want to run it. I think it's ugly, and I try to never do that. So, but you might see that other places. You might see some modules other places. All right, so that's our math module here, which is super cool. Let's see, yeah, square roots, ceil for rounding, factorial of numbers, fmod, which is right the remainder of division. We can already do modulus here. Exponents, powers, trig things, complex numbers, math constants. We get all sorts of cool things here, right? So we don't have to reinvent the wheel here. That's sort of the goal. This is really fun. So if we wanted to, we could go ask them to enter a number. Oh, we could do that for lab, actually. We'll save that for lab. We could calculate the standard deviation of a bunch of numbers. Right? You all remember how to do that? It's been a little while in your math class, right? But we did standard deviation. Not a lot of you are nodding. I'm a little concerned. Is standard deviation not something you've calculated before? I'm sorry, now I don't know if you're nodding yes, you've calculated before, or yes, you've never calculated before. Okay, all right. It's just a formula, and we can do that sort of thing with code here, right? Which is nice to not have to do it by hand, because it's a big pain to do that by hand. And I think that's why our calculators had a way for us to do that. right? Was there a shortcut in the TI calculators for standard? I think there was one for standard deviation, but you had to get like, I forget. It's all right. It'll be lots of fun. You guys will enjoy it here. We'll calculate the standard deviation of grades, which is super exciting here. Just as a fun fact, when you ask someone to curve grades, generally that's the wrong term. And I'll be real pedantic and annoying about it here, but you don't want a curve on your grades. A curve is a bad thing here because generally what that means is you get the bell curve. It'd be nice if I could spell things right. The standard bell curve here, this is not a very happy curve because the middle here would probably be C, right? And that means everyone within one standard deviation is going to get a C, and then barely anybody's going to get a B, and even less people are going to get an A, right? You don't want your grades to be curved. Curves are bad things. What people ask for when they want a curve, what they really mean is they want everyone to just get bumped 10% or whatever. Like, hey, if the highest score was 82, can you just pretend that's 100 and add 18% to everybody? That's not a curve, right? Can we agree on that terminology-wise? Okay. I know I'm really annoying being specific about terms here, but you don't want curves. You just want bumps or adjustments or something like that, right? Good question? Okay.
Took me out of this class.
Okay.
So, unregistered for your other class.
I would ask whoever helped you because if you unregister now, it probably won't let you back in, is my guess.
So it says like at this class.
Then go for it.
Yeah.
If it screws up, you can go ask. Yeah, that'll get you the right one. Yeah. All right. So curves, we got to be careful. That's all with our curves here. And again, we're all math people. You might not all be data science majors, but we all like math and appreciate math, and that's why we're probably here because we like that sort of thing. So don't ask for curves. Okay. All right. So yeah, math is fantastic. You know, distance between 2 points here is really nice and easy. You can calculate the distance between 2 points, and you'll do that exercise here, right, in the math module, right? We can do these sorts of things. We're good at that, right? Is that even trig? Or is that just algebra? Distance between two lines? I guess it uses trigonometry. I don't know. No one cares enough. Okay, that's fine. It's not important. It's unrelated. All right, random numbers. This is super cool. So using random numbers is really fun because it makes our program look like different things are happening every time we run it, which is true because it's using a different number. Now, the word random here is a bit of a misnomer. It's not actually random. It's known as pseudo-random or sort of random, almost random, because when the computer runs its program, it's doing this step and then this step and then this step. It's doing the exact same thing every time. So it's not actually random. What it does behind the scenes to make it look like it's random is it generally bases it off of the clock time on your computer. So when you ask for a random number, it says, hey, what's the time? And uses that as like a starting seed value somewhere. And then you get a random set of sequences. So every time you hit run, because time never goes backwards, it looks like you get a different set of numbers. Right? That's pretty reasonable. But if you know that starting value, then you can calculate and predict. I mean, predict's wrong, but you can follow the formula to get what the values are going to be. Right? So, because it's only pseudo-random. So there was a Russian hacking, maybe hack's the wrong word, a team that went out and were cheating on slot machines because this particular manufacturer of slot machines was stupid, and they used the same random number sequence generator to display the flashing numbers on the slot machine that they did to calculate the actual ending value here. So they would have a little camera in their pocket and record the screen and send it out to a computer somewhere, which would crunch some numbers right away. Be like, okay, based on this one and this one and this one and this one showing up, I think here's your seed. And it would send back a signal and say, okay, hit stop now. And they were like 75% more accurate. And the casino found out that something was happening because they realized they were losing money on their slot machines, which should never happen. I mean, casinos don't have slot machines to give away money. They have slot machines to make money. Right? I think that makes a lot of sense. So when they realized they were losing money on their machines, they're like, this isn't supposed to happen. What went wrong? So don't use the same random number generator for a display as you do for the actual calculation if you don't want someone to take advantage of it, I guess is the moral of the story. Sure, that's one thing. So just you know, don't use it for anything important. So pseudo-random should only just be for like toy things. not important things that should matter if they're random or not. So in games, that's fine, right? In cryptography, there are cryptographically secure random number generators, which I don't even understand how they work. I'll just be honest. Really smart people who have PhDs have researched this sort of thing. They know how it works, and I'm happy. And they publish papers on it, and everyone else is like, yeah, this seems like it makes a lot of sense. I'm okay with it. Sure. Something about elliptical curves. Okay, that sounds really neat. I'm sorry? Yeah. Yep. Yeah, generating random numbers securely is very important. So all of modern encryption is based on that. Being able to securely generate random numbers, essentially. It's really cool.
You didn't make a mistake. I got my schedule ready for this is data science. I know that. I meant to be in another class.
Oh, okay.
Every single one.
It's all right. We'll make it work. We'll make it work.
So, I blame the internet for being down.
Definitely, yeah. Things got a little crazy last week, so we'll make it work. Don't worry. And if you're in my class, then they're all recorded anyway. So, no biggie. All right, so random number generation. Again, we'll just acknowledge that this is a toy, essentially, right? Not for important things, but we can do it pretty easily. You can say import random, and then you say random.random, because random is the module. Random is a function in the random module. Hey, I'll see you Monday then.
Yeah, I'll see you in the actual class. Nice meeting you guys. You guys are chill. I'm checking this stuff.
So random.random, right? Oops, I gotta go. It tells me, hey, unresolved reference random. PyCharm says, I don't know what this is. You didn't tell me what random was. So thankfully, it knows that random is a well-known module, and I can say import this name. I can say import from random, and now I get import random. Right? It adds the code for me. Or you can go type it. This one's not hard to type. So now when I print a random number, we'll get a random number. Let's do like 5 random numbers here, right? And we'll give that a run. 10, 10, 10, 10. There we go. And we get, oh, well, those are really useful here. Those are super useful numbers. So random.random gives you a random number from 0 to almost 1, not including 1. Nice. So we know math. We can take this to get a result that we want, right, if we cared. So if you wanted the number, say, 1 to 10, right? So let's say print random number 1 to 10 is going to be random.random, right, times 10. When I multiply by 10, I'm going to get between 0 and 9, right? Because I'll never get 1 here, right? And then that is going to give me a decimal, though. I don't really want the decimal. So then I could take like modulus 10, which will get rid of the decimal, will give me the whole digit remainder here, right? Because if I divide out, take the remainder of divided by 10, it's just going to get rid of the decimal places, because I'll still have 0 to 9 with no decimal places now. Then I can add 1. This is really ugly, right? Times 10, modulus 10 plus 1, just to get a number 1 to 10. But it ought to work, right? Let's do 5 more numbers, 1 to 10. 10, 10, 10, 10. Here we go. Now, oh goodness. Why? Did I order of operations wrong? I think I did the order of operations wrong. Yeah, I think I did 10 mod 10. Is that right? No. That should have worked. Hang on. Let's see. So 10 times 10. Some parentheses here are important. We'll try that. I think this will do it here. And this is what I get for copy pasting it 5 times. I have to fix it 5 times. Okay, let's try that. Nope. Really? Mod 10. Mod 10. Yep. What? Not have the decimal places. I want an integer. We could do the integer division, yeah, if we wanted as well. Let's see. try that. There's an easier way. I'm doing it the hard way on purpose here. Seriously? All right, now I'm confused, but that's okay. Yeah, we could use int if we wanted as well. To say, hey, I want an int of this. And that'll definitely work as well. Int. Then we probably don't need all the other parentheses then, right? Get rid of a couple of them. Int. So modulus gives us the whole number remainder. So when we have just random here, we only get between 0 and 1. So I'd expect that to not be anything big, right? Because that should only ever be 0. Let's see. Hey, okay, there we go. So tell it we want an int. Now we get numbers here. Hooray, we get some numbers. Now, this is really obnoxious. This works, but Python realized, like the fine folks who wrote Python, said there's got to be an easier way, and there is. So random number 1 to 10 here. Let's do it the short way is random.randint. If you want a random integer, you ask for a random integer, it says give me A and give me B. Now this is confusing, but you give it the low number and the high number inclusive. So randint takes low and high values inclusive. Which drives me nuts. Most other languages you don't include this one, but Python does because they're special. So we can do that now 5 times, and we should get 5 more random numbers. There we go. So these ones here, 77413, 92839, these look pretty random. We still haven't gotten a 10 yet. Let's make sure we can get a 10. There we go. Now we get a 10, right? So it seems like it's working, right? We get all the way from 1 to 10. I thought we had a 1, right? Yeah. So they're just telling you, hey, I need an A value and a B value. A is minimum, B is maximum. This is terribly written, which drives me nuts in their library. It should be min and max. So this is PyCharm being helpful, saying, hey, in the library, it's asking for an A and a B, which is dumb here. So you can actually go and find your Python install. I think I've got mine. Python, program files, Python. One of these ones here has it. Python, nope. Shoot, where is it? Is it, there's virtual environments here. So let me go find, I think I've got it here. Library, nope. Goodness. Where does it have it all? I've got Python installed. Oh, I think it's in my users directory, that's why. This is not very interesting. Hang on, I can find it. Where is Python? PyCharm projects, no. Yeah, I gotta find where Python's installed. It'll be worth it, I promise. It's very interesting. Projects, Python interpreter. Show all. It's the virtual one. Really? Here it is. Okay, so C users app data local. Goodness gracious, that's messy. C users. So you only see the app data folder. That's annoying. Options. Show hidden files. Now we have app data. There we go. Local programs. Python. Python 3.10. All right. Nope. Lib. Nope. So here's the random py file. All of this to say, these are all the modules Python comes with. You can import just out of box, which is super cool. And you can go look at them. So we can open up the random file here and say, what's in it? And let's open it with PyCharm. Why not? It'll look pretty. This is going to look really messy here. Don't worry. It'll make more sense once we get a couple more chapters in, but this is fun. I think it was going to open. Is it going to open? Cancel those. There it goes. So here's random py. So in here, we can go find all sorts of things that we want here. So let's find randint. Randint. So randint takes an A and a B, which returns a random integer, a range A of B, including both endpoints. Sure. what it does, it uses the rand range function, which takes a and b plus 1. Sure, so rand range says, where's the start, what's the end here, right? It gives you a random int item from the range start to end, which includes the endpoint. In Python, this is usually not what you want. These other languages don't do that. So, sure. So this is all the code here. Eventually it'll make sense and we can read all this and be like, hey, this is really cool how it does it here, right? But that's fine. So rand range, where's it doing here? It runs rand below. Sure, that's fun. And you could like walk through and see all the different functions it does. It gets kind of messy. So it's not worth lots of time, but eventually we can come back to it and it'll make a little bit more sense. Okay, so that's the random code. So random is inclusive, just be careful. And there we go. All right, so random numbers, cool, random range, randint, rand range, yep, gives us that. Only moving seeds. Okay, so seed, so because it's pseudo-random, right, you can use a seed value and set the seed value. Instead of it being based on the clock time, you can fix it so that every time it runs, you'll get the exact same thing. So I can say, hey, let me set the seed to something, and then every time I run it, I'll get the same results. So sometimes this is useful if we want to get a predictable set of random values, pseudo-random values. Most of the time, we just want it to look like it's random every time we hit run. So generally, we don't set the seed, but you can if you want, and then you'll get the same sequence every time. That's all. That one's kind of fun. Random numbers. All right, text is really cool. Did we talk about binary and storing things as zeros and ones? I think we did that. So if you take that thought that everything is stored as zeros and ones and numeric, eventually you'll come to the idea that you can't actually have text. Right? Because if I want to have text here, well, it's letters, not numbers. So you need a way to represent letters as numbers. And this introduces the ASCII Unicode table. So the idea is every letter is represented by a digit. This is the Unicode table. So you can get from 65, which is the capital A, all the way to lowercase z, which is a 122, to represent our characters. So every letter that we have will be a specific number when it's stored. And that way we can store text as numbers and just put them all together in memory and say, hey, here's a bunch of numbers, please read them as letters. And that's how we get our strings. So we can get different values here out, which is really fun. Where to go here? So yeah, you can get an individual character if you want, or you can get the number value back out. So if I wanted, I could say, hey, let's do a random password here. So let's generate a random password here. So here's print. Here is your random password. And I'm going to take a random number. Now I want between, let's just do all uppercase because it's easy, 65 and 90. So I'm going to print the character value of randint 65 to 90. Right? And now when we're printing here, there's something, I don't know if the book showed you yet, if you had a chance to read it here, you can change the ending character so it doesn't go down a new line here and say, hey, just end with nothing. Don't go down. So setting the end to, that's it from to the next line. So I'm going to run a bunch of these together here. I don't want to even comma separate because I want them just to run together a bunch here. Let's do, here's 5 letters there all together. And then this last one, I don't need to set the end because I want it to go down. So this should give me a random 5 letters now, because I asked for a number 65 to 90, and then I said, hey, please turn it into a character. So 10, 10, 10, 10. Here we go. So our random password is HXGCR, because we can turn numbers into letters. What's the what? Char? This is a character. So it turns something into a character. It turns a number into a character. Yep. Yep. Yeah, so using this table here, you can generate any character on your keyboard. And actually you can go, because people finally figured out there's more than just the letters on the English keyboard, that you need like other characters. And then like other fun things, and letters with accents and things like that, and even other languages can be represented in Unicode as well, which is pretty fun. So basically any character you want, you can get eventually here in Unicode, right? So you can just go look it up. They used to have a char map. Do they still have that? Yeah, character map. So in Windows, you can go to this character map thing, and you can go find a bunch of characters. Like, here's all the different characters you can make in the Arial font, which is pretty cool. And it will tell you what it is, or you can just go copy individually and say, hey, I want to select this one and copy it. Sure. It also gives you the alt character keystroke here, but that's fine. So we can go find it if we want. All right, so that is getting characters out. So other things that we do when we have strings, right, which is just a bunch of characters strung together. That's why we call them a string. A string is a string of characters, right? You might want to get certain characters in here that are tricky to print otherwise. So if you have a apostrophe in your name, like Mr. O'Donnell here, that can be really tricky to print. If you wanted to say, hey, let's print John O'Donnell, O'Donnell here, right? Like, notice it's kind of green and now it's not green anymore and I'm getting red lines because I've put the ending quote symbol here. Now you got two options. The easy option is to just use double quotes here. Donald here. If you have double quotes, a single apostrophe is fine. It's like, oh, sure, I know that's just text. That's okay. Or if you wanted to print, Eric said, stop. If you put that in single quotes, then you can use double quotes inside your string. So you can mix and match here, but you can't have the same one inside of it. So if you need the same one inside of it here, so if we're going to say print, this is John O'Donnell said stop, right? To do that, you would use the backslash or the escape character. The backslash is the escape sequence telling Python, hey, the next thing I'm putting in here is special. Please just treat it special. And then the ending quote to match this starting quote here. Or you could also put that after a slash here if you wanted. So you can use the escape character to say, hey, I really want a single quote or a double quote. Or if you want a backslash in your output, you have to escape the backslash and say, hey, double backslash because I really want one backslash, which gets to be really annoying. But you can do those sorts of things. You can add in your own new lines. You can say Eric said, and then add in your own \n, which is a new line, and then stop will show up on the next line, right? 10, 10, 10, 10. So now Eric said stop, right? Because I added my own new line is on 2 lines. And you can add as many new lines as you want, right? Remember, print by default gives you 1 automatically. That's why you can change this ending character if you want, if they all run together. Sure, that's fine. You can do tabs. Tabs are fun for lining things up, but they're not super interesting. Now, raw strings are really fun. So raw strings said, hey, just treat everything in here as not escaped. So if I give you a raw string, you don't have to add, I'm sorry, so anything that is escaped, it's going to ignore. So if I say it's a raw string, it just reads what's in it normally. It says, hey, just take it as is. Don't try and escape anything here. So raw strings can be helpful because you can put in all sorts of quotes and things like that in there we don't need to do all the escaping things in them. So you'll see some people use raw strings a lot, depending on what they're inputting. So it's like, this actually has my backslash in here. Sure, perfectly fine. Characters, yeah, that one's good. All right, cool. So because we can turn letters into numbers, or we can turn numbers into letters, right? We can go back and forth between the two. So my name, Eric, right? We can say, hey, let's print the ordinal value of an E, and we'll do this one letter at a time, E, R, I, and C. Right? I can get the numeric values back out of Eric if I want. 10 and 10 and 10 and 10. Right? So 69, 82, 73, 67 are the Unicode values of ERIC in all uppercase. Now it's fun if you wanted to shift my name or do some, encryption's a bad word for it here, but it's a cipher is probably the technical term for it. I could take the ordinal value of my letter, add 1 to it, and then turn it back into a character. So get the ordinal value, add 1, turn it into a character. Or even let's get an int here. So let's get a shift. Shift is equal to an int of an input. How far should we shift letters? And then we'll get the shift here, and I'll add that shift to it here. And I'll do that for each of these. So we'll do E, R, I, and C. Oh, goodness. E, R, I, and C. So we should be able to shift all the letters by some number of characters. Because I'm just going to add that value to it and then turn it back into a character. It's like a simple substitution cipher, almost. 10, 10, 10. All right, so 10. So what do we want to shift by? If we shift by 2, E should turn into G, right? R should turn into T, I think. That sounds right. And then we get the encrypted, or not really encrypted, but a different version that we could translate back into Eric if we wanted. Right? To undo it, we would take the new value, subtract, turn it into its ordinal value, subtract the shift, and then turn it back into a character. Right? Now the problem gets to be if you have a Z in your name or your shift is really large, you start to get some really funny characters. So let's run this again here. Actually, let's just do, I think I learned I can do this. It saves a lot of time. I can right click and say, so just run execute selection. Here we go, execute selection. Yes. Let Python do that. Come on. Allow access. Here we go. Okay, so how far should we shift the letters? It looks a little different here. Don't worry too much about it. So if we shifted by like 20, now we get capital Y, lowercase f, the ending square brace, and a capital W. Sure, that looks a little weird, but it works, right? Because we get some weird characters. So if you want it to wrap back around, right? If we only ever want to get between 65 and, what was the value we wanted to stop at? 90, right? We need to say, hey, if it gets bigger than 90, we need to do something here, and we have to add something to it. It gets to be a little bit messy here. But essentially that range is 26 values, right? There's 26 values between 65 and 90. So if we take the value and then mod 26 and then add 65 to it, we're guaranteed to get a capital letter, right? Yay, math. You all look super interested, I'm sorry. Oh, wrong one here, this one. So let's do that. So let's say, okay, let's add the shift, but then before we turn it into a character again, let's mod 26 and then add 65. Right? Because then we get to a range between 0 and 25, right? We should get a whole number between 0 and 25. We divide out all the 26s, and then we'll add 65 to it to get back to the capital A. And now I won't get lowercase letters, and I won't get these weird square braces anywhere. Here. E, R, I, and C. Right? Why does it not like 65? Unexpected variables. Is my character's in the wrong place. Oops. There we go. So it's just telling me my parenthesis was in the wrong place. There we go. It didn't like this. Didn't think I could add 25 to it. Okay, so now I have character, parentheses, and here. So this whole ordinal plus shift mod 26. And now the problem is order of operations is going to apply. So I'm going to take my shift mod 26 because we're doing order of operations. So we want to make sure we're doing the ordinal first. Thanks, PEMDAS, right? Order of operations still applies. Take that, mod 26, and then add 65. Right? Does that make sense? To make sure we're doing this in the right order? Yeah. So modulus 26 should give me the remainder of divided by 26. So I should get a number between 0 and 25. Because there's 26 letters, so I get that range, and I can add 65 to that to get back to 65 to 90. So it should keep me in the, keep within a range of 26 values, add 65 to get back to capital A, right, in that Unicode table. Right, just doing some silly math. So we should be able to get any sort of shift now we want, doesn't matter. So how far should we shift? If we did 20 again, now we should get capital letters still, right? If we went too far, that's okay. We just mod 26 and add our 65 back up here. So E plus 20, oh, I don't think that worked quite like I expected. E plus 20 should have given me like Z or something, right? Interesting. But we're getting capital letters. I wonder if we, that's fine. It's not that important, right? We get some letters back up, so that's all. Is that okay so far? You look bored, I'm sorry.
No.
All right. So now that we can do this sort of thing, right, we can make an app that scams people out of money. So I don't know if you heard, there's this app for Gematria. I think that's how you spell it. Gematria. Here we go. The Gematria calculator. This is some conspiracy nonsense that people have gotten into, and people are taking advantage of that. So go for it. That's wrong. You should not take advantage of people who have fallen into conspiracy traps. I'm sorry, but I'm going to make fun of them. Is that okay? That's probably also still wrong. I'm sorry, but we're going to do it anyway. So people think that you can take a word and get the numeric values of all the letters and add them together and get a number, and that number must mean something. And if two words add up to the same number, there must be a connection between those words. I know. Your look is great. I love it. It's insane. Like, people actually think this is the thing. And I have no idea in my head. Like, it hurts me to watch these interviews with people. They're like, oh yeah, I added up the number success, I added up this other number, so this must be successful. They're like, no, that's not how any of this works. But people do that. So there are apps you can go buy. So take a look at your app store, just search Gematria and see how much they're charging for these stupid things that we can write after like 2 weeks of Python code, right? So we'll ask them, sure, let's enter some letters. So we'll say, hey, so enter, so we'll get a, first letter is an int of an input. Oh, sorry, just an input. Enter your first letter. And we'll just do this for a couple different letters here. Let's do 3 letters because I'm tired of copy pasting. So second letter, we'll see if we can find connections between 3-letter words here. Second letter and third letter. Okay. Then we'll go add them all together. Okay, so we're going to, a result then is going to equal the ordinal value of first letter plus the ordinal value of the second letter plus the ordinal value of the third letter. And then we can print the magic value of that word is my result. Okay? I know, it's as stupid as it sounds. So let's execute that. So what's a 3-letter word? How about like cat? C, A, and T. So cat is 216. So if we come up with another word that gets to 216, it must be related to cat. Now, I can't do this math in my head to figure out other words that relate to cat, but that's okay. So we'll run it again. So let's execute that again. So let's try it again. What else? What other 3-letter word can we come up with? What? Bat? B-A-T. 215. So bat and cat are not related because they don't come up with the same number. Obviously, they're completely different things. All right, let's try it again. Lie? Okay. Uh-oh, that's the wrong place to type. L-I-E. 218. Ooh, we're getting close now. So lie is close to cat. Not quite. Should try it again. Execute. What is it? Dog. I'm sorry. Oops. Oh, I did grab the wrong. What happened to all my code? Oh, there we go. I overtyped it. My mistake. Let's try that again. E-O-G. Dog is 229. We have not found a connection yet. You guys aren't trying hard enough. Cut? Car? All right, let's try car. Let's run this. Goodness, why do I keep doing that? C-A-R. 214. Oh, do we get a 214? 218, 215. Nope, we've not gotten to 214. All right, let's try it again. What? Bar? What about like war? WAR. 234. Oh, too much. 234. But anyway, it's as stupid as it sounds. People will go through and just type in words until they get matching numbers here. And the video I watched, someone came up with a connection here between things because they took someone's first initial and then their last name. Not their whole name. They're like, hey, if I use this and then their last name, it comes up and it matches this. It must be related. You're like, if you have to try that hard, don't you realize this is dumb? They're like, no. If I use the whole name, it's not actually them. Like, come on, people. Yeah. Act? Yeah, for sure. Let's do that. We'll try A, C, and T. 216. Ooh, we had a 216 before. So act and cat. Act and cat must be related somehow. And it's up to you to come up with this relationship because obviously, if you're into this sort of thing, you're super smart. And no one else is aware of these relationships aside from you because you found these numbers here.
I mean, also, the labs are the same.
Yep.
Oh, yeah.
So yeah, it's painful. Just like go search some videos if you're bored. You can. It's actually like it's fun that we can laugh at people for being so dumb, but also really sad that like in America here there are people who like really think this is a thing.
So we're not serious.
It is like the people are convinced of this, and then they go and make choices based on being convinced of wrong things, and like it's painful. But again, takes all kinds of people. So I love education and higher education, and maybe we can make people smarter. So sure. All right. Anyway, so that's all sorts of nonsense there with Gematria. Seriously, go look up how much the apps cost. It blows my mind how much money people pay for these things. It's ridiculous. I'm sorry? What? Gematria? I think. Gematria? I don't really care how it's pronounced because it's dumb anyway. Oh, here we go. Let's see. No, I don't want an ad. Calculate the Gematria. Oh, in different languages, or simple versus English, you get different numbers here. I don't... Ryan Boomer? What? Didn't I say I'll be back? What are these people doing? A star family? Illuminati hate cannabis? What? Yeah, people have gotten some weird things. The big guy? What? I don't even like. Sort of hurts my head here. View the rude words that many people have used. Like, here's you can get a Chrome app, demonstrating statistics, a database, and numerology. Here we go. We gotta get into this one here. Like hello equals devil. Obviously. Okay, I'm sorry. That was a weird rabbit hole. When you watch some of the late night comedy things and they just go talk to people, you get down some weird places here. So, again, maybe the writers will go off strike soon because they'll get paid a decent amount and we won't abuse them with AI sort of things. We can get back to having decent shows to watch again. But, we're down to third string stuff. So, which is actually interesting because people think this is decent time for individual content creators to make a name for themselves and distinguish themselves when you don't have the mainstream content to watch with no writers and actors. So it's interesting. So, also weird, there's no child labor laws around making your kid a YouTube star. But if they go work for a production company and like on a movie, there's all sorts of child labor laws they have to follow. So, weird. I suppose. They assume you wouldn't want to do bad things to your children. But parents who want their kids to be famous do all sorts of really weird things too. So, all right, anyway. Where were we? Unicode. All this from Unicode. Wow, that was fun. Unicode. All right, so representing text. Yep. All right, so I got to turn on the labs here for chapter 2. I'm sorry. I thought I was going to do that and must have forgot to do that. So let me turn on a couple of these labs for you here. Make this visible here. The chapter 1? Didn't I turn those on? No, so I turned on the first couple. After that, it's just really redundant because it's all like, it's just really super basic stuff. It's not really worth all that much practice. So I'll turn on the other ones here. We only need to do a couple of them here for chapter 2. I don't think we need all of them. Let's see. Formatted output is fun. Let's do this one. And so this is the one where like every space needs a lineup, right? And you're going to be upset for a little while, but it's that attention to detail practice is useful. I'm going to tell myself. So that's all. And then the Mad Lib is fun too. All right. So we'll just do those ones. So if it's hidden, don't worry about it. You can ignore them. I can actually go, I'll move the hidden ones out later. That way they don't count against you or anything. All right, and then for 2, musical note frequencies is fun. This is a good one. The math functions is not all that interesting because they're just math functions. And then converting to dollars is good too. Okay. All right, so a couple labs for 2 for practice. We got to talk about the next project. And then I think we're good. And we'll meet up next Monday, start at chapter 3. We'll have our lab on Monday after class. And we should be in good shape. All right, so I have to set up a link here. This won't make any sense, and it's okay. Don't worry about it. We'll practice this in lab first, and then if you have questions about it for the project, let me know. But this is setting up your GitHub repositories. I just need it here, so it's there. Fall 2023. This will be for project 0. CIS1, 3, project 0. So this will make a Python repository or GitHub repository for you that is private, so you'll have access and I'll have access. Again, we'll practice in a lab on Monday, so don't worry about the workflow right now for it. I just want the link out here so you can have it for the assignment. All right, let's go to assignments for project 0. Why are there 2 groups here? That's weird. So project 0, they'll be due in 2 weeks. So the 20th at 12:30. Right, and the idea is I'll go over the solution in class. So got to be in, right? I can't take these ones late. So please submit the URL to your repository. Add screenshots to the README program running. And I'll show you how to do all that again. It doesn't have to make a lot of sense right now. That's okay. So you're going to submit online as a URL, which is great. Okay. Points.
So that's the first part.
Yeah, this is project 0. This is our first project. You can do all of it except for one part with what we've talked about today. Next week, we'll get into the branching stuff so you can finish it out. It's just without that, it's really dull. So most of it you can do. Don't sweat the other part that we can't yet. We'll get to that. We can go from there. So we're going to write a program that helps a user plan a party. Okay, so first we're going to ask the user for their name, and use that in all the following prompts. So you like when the computer talks to you, right? It makes it seem like it's a nice personal computer that wants to have a relationship with you and get to know you and it cares about you. Right? Have we done that input with name and stuff? Do we do that? You can say like, hey, name is an input. So instead of doing integers, just your name, and I can print my name, and then maybe we'll have another input for, I don't know, feeling is an input of how are you today? Name? And a question mark? Right, sure, why not? And then we don't actually care how they're feeling. We'll say, oh, that's nice. Right? Because we haven't got to that point of being able to figure out what they entered. That's okay. We'll just say that's nice. Okay. So if we run this one here, it says, okay, enter your name, Eric. Hi, Eric. Input. Oh, shoot. So with input, you can't comma separate. That's what happened here. My bad. So with input, you have to concatenate or add together. So concatenate with strings is just fancy for smushing together here. The problem with concatenating is you don't get any spaces. When you comma separate in print, you get spaces. Input, so can't use comma separated output in input. But you can in print. Okay, so you have to add them together or concatenate. That's our fancy term for taking a string and adding another string is just sticking them together here. So you have to include the spaces. Because with printing, you get the spaces automatically with the comma separate. Okay, that was all. Let's try that one more time. Let's run that. All right, so Eric. Hi, Eric. How are you today, Eric? I'm good. Oh, that's nice. Sure.
Yeah, why don't you separate the instructions and the comments?
Why did I do what?
Instructions.
So in the input, you can't have commas. So that's why. So if you're using an input, you have to do the concatenation bit here. If you just print, then you can do the comma separate, and you'll get all the spaces, and you can add variables and things like that. Yeah, so it's just because I'm using input here. So the other option you have is you can just print this here, and then you can comma separate. Right? And then you can just use a regular input with nothing. So if you print and then use input, right, feeling equals input, you can do it that way. So either option here will do the same thing for you, right? So I'm just going to leave that one commented so we don't do it double. So this is example using print first. So if you like the comma separate, you could just print it and then do an input with no prompt. If you want to do it all in one line, you do an input with the concatenation, not commas. Just a style preference here. At some places here, and it's not a good measure, and everyone knows it's not a good measure, but some organizations will measure how, quote, productive developers are by how many lines of code they write. People love to measure things. Like management loves to measure things. It's, you know, sure, it's something to look at. So if I'm getting measured on how many lines of code I write, I'm not going to write this one. I'm going to write this one, and boom, I'm twice as productive. It's silly, right? Like we acknowledge that it's silly. Everyone knows it's pretty silly here, but that's one thing. Some developers pride themselves on writing the least amount of lines of code to get a job done because they think that's clever. Sure, I mean, whatever. As long as it's readable, I don't care how many lines it takes, right? At some point, using a single line that's like this long sucks. Using 50 lines also sucks because you have to look through 50 lines. If you can find some happy middle of like 10 lines of code that are decent size, I'm happy, right? Python doesn't care, right? The code's for people, for you to read, for your team to read, for me to read so I can evaluate it, that sort of thing. We just happen to write it so that Python can also understand it. Right, but the whole reason we write code is for people, so that we can read it and see it. Oh, this chair is squeaky, sorry. And from there. All right, so we're going to ask for the name using all the following prompts. Okay, we're going to ask the user what they are serving at their party. So what sort of things would you serve at a party? Like pizza or what else? If you're not serving pizza, what might you serve at a party? So beverages, drinks? Drinks? Okay, pizza, drinks, any one other. Pizza, drinks, or ice cream? Sure, ice cream. So we'll call these the, quote, valid options. If it's not one of these three, we're going to tell them to try again. And we'll talk about that next week. This part needs chapter 3. So don't worry about that part right now. So, but if they are serving pizza, oh, sorry, the next step then. So ask for their name, ask how many guests they expect to come. So how many guests will matter, right? If you're going to have 10 people to a party or 50 people to a party, it's going to make a difference here. Or maybe just 2 people. That's okay. So if they're serving pizza, ask them how many slices the average guest will eat. Right? So like, hey, when I invite my friends over, I know they usually eat 3 slices of pizza each. So if I'm going to have 5 people over, I need at least 15 slices of pizza to make sure everyone gets enough pizza. So I can then calculate things like how many pizzas do I need to order? You don't call up the pizza shop and say, hey, I need 15 slices of pizza. Or at least I don't think you do. You say, I want 3 pizzas, right? That sort of thing. So we'll ask the user how many slices come on each pizza. So depending on what kind of pizza you order, right? It might be an 8-slice pizza, it might be the 12-slice deep dish thing from Jets, it might be something else, right? Whatever, right? You might get different numbers of slices. So we'll ask how many slices on each pizza. then we'll calculate how many whole pizzas, not 3.5, right? You need to order. Ask the cost of each pizza and display the number of pizzas and total cost, right? So, hey, you're going to have 5 people over. They each eat 3 slices, right? How many slices do we need altogether? Don't forget yourself, right? If you're having 5 guests, you're also at the party, right? So that's 6 people. So you need at least 18 slices of pizza, not 15, right? Don't forget to count you. You probably eat at your own parties, right? So 18 slices of pizza. If I get 8 sliced pizzas, I need 3 pizzas, right? But that's math we can do in our head. But we're going to make Python do it for us. And again, this is just our first practice here, right? That makes sense for pizzas? Yeah.
What the options?
Yeah, we'll get to that next chapter. So if you just want to just do the plain pizza to start, get started on the project, that's a good place to start. Just pretend it's always pizza. Don't even bother asking, right? So then if they are serving drinks, ask them how many ounces, milliliters? Should we do ounces or milliliters? I don't know if it matters. Ounces each guest will drink on average? Sure. Okay, and then we will calculate the number of gallons required to purchase, ask the cost of each gallon, and then display the number of gallons and total cost, right? Hey, if each person drinks 16 ounces of beverage, right, I need to buy this many gallons. Again, whole gallons here, right? This is number of gallons, number of whole gallons, so not 3.5, right? So round up, so you buy whole gallons, right? Depends what beverages you're serving, I guess. It gets confusing because usually we buy pop in liters, or if you're buying alcohol, you buy it in fifths, which is also in milliliters. I don't know why it's called a fifth, but I'm sure, fifth of something. I don't know what. Sure, but we can do ounces. Ounces and gallons is fine, okay? So do that, and then if they are serving ice cream, ask them how many scoops each guest will eat on average. Ask them how many scoops come in a container. Calculate how many full containers, not 3.5, we need to buy. Ask the cost of each container and print the number of containers and total cost. Right? So nothing like super crazy here. We're just practicing some basic arithmetic here, making a program, but it's going to be different based on what they want to serve. Right? Does that make sense? All right, cool. So then let me add this here. Okay, so we got points here. That's good. So we publish this, and I'm going to add a rubric. Okay, so let's do points here. So generally with this is project 0. You either did it or you didn't do it. So this is asks for name and uses it in prompts. So you're welcome to like score yourself partial points. I'm going to ask you to score yourself. I'll show you how to do all that in a little bit. But when I go through and grade it, I'm just going to click yes, you did it, no, you didn't, or if you like sort of did, there's partial points. So like if you ask them for their name, but you didn't use it in the prompt, you might get 1 out of 2, right? Great. If you asked the name and used it in most of the prompts, but forgot one, I'm not going to mark you off points because like you showed me you could do it, essentially, right? I'm trying to be generous with the points, right? All right, so we ask the user for that. We can calculate, ask for number of guests. Sure, we'll make that worth 2 points, and then calculates its pizza correctly. Sure, that's 2 more points. Calculates drinks correctly. And calculates ice cream correctly. Okay, so 10 points total. So 2 points for each of the options, 2 points for getting the guests, 2 points for their name and using it. So pretty basic start to our first project here. On Monday, we'll do a lab that practices this GitHub workflow and does some basic arithmetic. Relatively similar to like one of these, right? And they're all pretty much the same. They just change a couple things around, right? It's nothing too crazy here. So Ideally, this is easy for you. I'm happy if it's easy for you. If this is hard for you, let me know. Right? And again, you don't feel like you have to do it today. Right? But in the next week or so, hopefully you can get it done. We'll talk about the stuff you need next week. For this part, you've got a little more time because it's not due for 2 weeks. Right? So we'll go over some material, but hopefully get this done and knocked out. It's a good, easy start for this. Okay. With projects, they are your individual effort. Right? Don't go feed this entire thing to ChatGPT. Right? Because then you're not turning in your own work. You haven't added any original effort here. Right? If you're not sure how to do a specific thing, like, hey, how do I round up? Sure, go ask ChatGPT, go Google it. Whatever you want to do is perfectly fine. And then you cite that as your source. Hey, here's how I did it. Now, apparently I'm behind the times. The ChatGPT site will give you a link to your thread, your conversation. The UMISH site did not, that I could tell. I couldn't link to that. So again, in your citation for it, just put in, hey, here's my prompt that I use. So we'll go to UMGPT here. Get logged in. And we can say, how do I round a value up in Python? Right, so it's got a chat. I don't think, is that linkable though? Let's see. So here's some math.ceil. We'll round the value up. Sure, we can go do that. So I don't think it's linkable. Yeah, it's not, there's no link to it here. So you'll just give me, hey, here's the URL. So we can say, here's for, I got the rounding method from, my prompt was this. Right, perfectly fine. No worries here. So we can print 4.2 rounded up is math.ceil, seal for sealing, if that makes this make any more sense here, right? Great, rounded up. This is also in your Zybook. Perfectly fine. If you got something out of your Zybook, please don't feel like you have to cite it. I'm assuming you've read the textbook, right? Like if you copied an exact line of code out of Zybooks, yes, we should cite it. But like the material there and the things I tell you, you don't need to cite. Like I'm assuming we all have that as the base, okay? But if you go out online, want to find something on Stack Overflow, want to find something on ChatGPT, just drop a little comment in here like that. That's it, great, okay? Now again, don't give it the entire project. It'll do it for you. Like you can just copy this entire thing in, it will give you Python code, but you can't turn that in, even if you cite it, because none of it's your work at that point, right? It's English paper rules. You got to have some original effort here. Is that, yeah. So just right before you use it, like right here, I put in a code comment. Yep, yeah, just leave a code comment so it's right in your code, right here. Python will ignore this, and I will be able to see it and say, okay, cool, you did that, right? Works out great. Okay. Does that make sense? All right. So again, use the tools. Great. I don't think you'll need lots of help for this, is the goal. Ideally, you can just do this by next week. Right? Is that, yeah?
It's a little bit out of topic. But what is the latest version of Python? Which version is it?
Just 3 whatever. Let's see, what's here now? It's 3.11. Yeah, 3.11 looks like the latest. I've got 3.10 because I just haven't reinstalled it lately. It really doesn't matter. You probably should stay up to date for just security reasons. I don't know.
Like mine is 3.9.
That's fine. I'm sorry?
Do I have to like download?
No, 3.9 will be fine. Anything 3 should be okay. Yeah, you'll be good. Yeah. Yep, no need to cite. No, so I'm assuming you've learned from the Zybook and maybe the things I've said. One of those two, perfectly fine. You don't have to add any notes there because that's like the baseline stuff we've done. If you go out and find more things, let's cite those more things, please. Yep. All right, questions, thoughts, concerns? All right, cool, we're ending like right on time. This is perfect. All right, so let me stop recording. I'll post this video. Have a great weekend. I'll see you on Monday for class, and Monday for lab will be our first lab. I'll walk you through this whole GitHub thing, repositories, README things. We'll do all of that first, right? And then if you have questions, let me know and I can help you out with it, okay? All right, cool, thanks folks.